Hello, Sam Switchtrack here with View, and this time we want to bring you Little Railroad II.3 wiring. Now before we get to that, of course, thanking all of our viewers and especially our subscribers. Now, the next segment here we're going to show how the control panel was reattached after the move from the previous home to this one. So let's get on with that. To start rewiring the train layout, we brought the control panel out here and started to untangle the wires. I'd like to say that these 2 kWs still need to be put on here in that area there. To help things, we've made a prior wiring diagram. All the wiring that goes out to the layout, including signals, track, switches, and uncoupler tracks, comes off terminal strips. So we're going to identify each wire with a tag, and then we'll put the control panel in place and hook the wires up. Here you can see we've segregated some of the wires out into types, and from that we're going to label each wire. And like I said, then we'll put the control panel in place and away we go. The KW transformers have been reinstalled on the control panel, and the control panel has been put back into its rightful place here. It's made to hinge up and down with these chains holding it up. The wires have all been labeled, and it's just a matter of hooking everything up. We've searched through all the boxes and hopefully found everything that's associated with wiring, including this pile of signals, including the signal bridge over here, and log-ons, terminal strips mostly that go with the signals, some wires, hooks to suspend the wires from below the layout. And I'd also like to mention there's a bunch of other schematics like this one here that explains how to hook up a II.3 signal so it operates with a switch tracks, with 2 switch tracks actually. So we think we have everything we need. Okay, now we'd like to have Elroy Electrical discuss some of the wiring details that he was responsible for completing. Elroy? Hello, Elroy here, and we want to show you how we wired this railroad. The first thing we're going to look at is the control panel to identify the various types of devices that we needed to wire up. Then, later on, we will go over the detailed schematics for the various types of equipment we did wire. So let's get after it. Okay, looking over our control panel, which has been lowered into the maintenance position, we have prominently 2 kW transformers. We have a QSI programmer, which is currently not being used. 12 block switches. Now they have 3 positions. The top position is one transformer, and the bottom is another one, and then the middle is turned off. Here we have our spring-loaded switch, standard Lionel spring-loaded switch controllers. We spring-loaded because the position returns to the middle position after you switch it. These here are being used for the uncoupler tracks. We don't have any automated cars or anything like that, or coil couplers, so we just use the middle electromagnetic section of it, and this is one uncoupler track 1 on this side, uncoupler track 2 on this side. Just a momentary just the switch you just hold down as long as you want, and then release it as spring loaded. Going on up here, we have an auxiliary transformer, which we plan to use for powering some accessory lighting and so forth. a standard run-of-the-mill outlet strip. Now over here, this strip here, all the terminals from all the transformers are connected to the strip. Then we connect our wires from there to, as well as from here to, and these block switches and so forth. Everything goes up to these intermediate terminal strips, which are largely hidden underneath the wiring, but they're up there. And from there, the wires go out to the layout. So on our famous drawing here, this shows more clearly what the outlet terminal strips are all located up in here. Some are for the track blocks, some are for switches, and some are for the uncoupler tracks. And this one right here is outputs to the signals. So let's move on to let's look at some of the devices that are actually on the board as well. Here is the type of uncoupler track we're using. We do have 8 of those installed on the layout. And we have 10 switch tracks of this type, 072 switch tracks. Then we have various MTH signals like this MTH signal bridge, and that 3/3 signal you see over there about right now in the middle of the picture. So let's go to our detailed schematics and talk about the details. Okay, let's start with the transformers. If you're going to use more than one transformer on the layout, you should phase them. So this is a short instruction on phasing. 2 kW transformers probably does not apply to electronic transformers. I'm not sure how you do that. The old transformers, the same procedure should apply to them, but my advice is to find out what you're doing before you go and do it. But let's go through this quick procedure for 2 Lion-O kW type transformers. They were first built in 1950. Use an outlet strip for the power cords. That way, when you plug them in, you know you're at least on the same line coming into your house. The power cords do not have a wide tang, which most modern plugs do. They have one wider than the other, so you could plug it in one way. These old transformers, you could twist the plug around and plug it in either way. Then what you want to do is you want to connect the U terminals together on the 2 transformers. Plug them in, connect the U terminals together. Then connect the voltmeter between the D output on each transformer. This should read 0 volts AC. If it's higher than 0, reverse one of the power cords, and that should do it. I just want to mention the constant voltage terminal D to U is 18 volts, and constant voltage terminal C to U is 6 volts. But you should be able to connect your voltmeter between the C terminals and have 0 volts, and the D terminals and have 0 volts. You can play around with it all you want. But yeah, that's the basic procedure for phasing transformers. Alright, let's discuss what a track block is. It's any insulated length of track forming a block. Now, of course, this is the last century type of control system compared to what's available today, but it works for us and we're staying with it for now. You use insulating track pins, plastic insulating track pins on either side of the center rail, regular pins on the outside rails, and you have to power that section of track, and it's usually done with the log-on. And in our case, we don't connect the outside rail terminal on our log-ons. We connect them through the uncoupler tracks, which we'll get to in a minute here. But in any case, use a log-on, and our power wire for the track block goes to one of those intermediate terminal strips, Then it goes to our track block switch, which has 3 positions: A throttle, B throttle, and off. And that's about it. For our uncoupler tracks, we it's a Lionel remote control track type UCS. That's the top view. We had 4-wire cable available, so we just used it. Now we connect the uncoupler track to one of our intermediate terminal strips. Now this wire here is a dead wire. It's just connected for fun. Actually, not for fun, for visual satisfaction, but it's not used. The U terminal from the transformer is connected to the outside rail via this terminal. So we have 8 connections. That's why we have 8 uncoupler tracks, and we have 8 connections to the outside rails. That's enough for the layout. Now we have 20 volts coming for activating the uncoupler track. It's actually 18 volts. The terminal on our transformers say 20 volts, but it's actually 18 volts. And it's constant voltage. So with this spring-loaded little switch that we pointed out on the control panel, we activate our uncoupler track through this wire here. Now the block power for blocks which contain uncoupler tracks can be run through this wire. And here's our this is connected to the center rail, and this is B throttle, A throttle, and off through our block switches. So that's how we hook up the uncoupler tracks. Now there is a quirky thing here. One set of these activation rails, which we don't use, gets backfeed through the coil when there's no current on the coil, and it actually turns into a outside rail connection, and it's close to the center rail. So if you have locomotives with wide rollers, they may tend to short out on by shorting across from here to these rails. It's either this set of rails or this set of rails. I'm not sure which one gets the backfeed, but you can go around that by maybe painting them with an insulating coating, or bending them out slightly. So we haven't really had much of a problem with that, but I wanted to make you aware of that possible problem. This is how we hook up the switch tracks. Switch track up here. Make sure to put these insulating pins here. If not, you'll get a short when the train runs that way. These are to activate the automatic switching mechanism, so make sure you have those pins in there. We use a constant voltage plug, 4-wire cable going to our intermediate terminal strip. This is our manually operated switch controller, which is a spring return. And we use the 20 volt output, the D terminal, which is actually 18 volt constant voltage tap, and that goes to the constant voltage plug. Now, the less voltage you have to operate your switch tracks, the better. We did try a resistor to optimize that voltage, but you probably need a better resistor for that. So anyway, moving right along. This is how we wire a MTH 30-11036 signal, O-scale vertical signal, to indicate the position of a switch track. These 2 wires coming off here are used as the signal activation wires. They go to from this intermediate terminal strip, and it jumps over to another intermediate terminal strip for ease of connection and changing things and so forth. Then there's another terminal strip placed right near the signal. So now we use we spoke with MTH a while back about how much voltage to put on the signals, and I think they said 14 volts. So these are 18 volts coming back this way, and our return voltage is 6 volts. So our difference is going to be 12 volts, so it can never go above 12 volts. Now, in order to dim down the signal to what we wanted, we put these resistors in here, values 220 ohm and 1000 ohm. And the black wire goes to the return, and this here dims down the red signal, so it's not as bright as the green. And there you have it. This diagram shows how to wire a MTH30-11024 3/3 vertical signal to indicate the position of two different switch tracks. The switch track wires are coming in here, the same signal wires that we illustrated on the last diagram, and this is our 6 volts return. So this terminal strip is located near the signal, and in this case we use two 220 ohm ones to dim down the reds, and a 470 ohm one to dim down the signal overall. Now if you put too high of an ohms resistor, the signal will not work, so you have to be careful when you're doing that to make sure you don't put the resistance too high. For the MTH11009 30-11009 signal bridge, it's the same idea, and in that case you cannot use a 470 ohm, you have to use a 220 because it doesn't work if you put the 470 in. Oh yes, we do have to mention that we remove the bulbs from the switch tracks, the ones that indicate the position of the switch track on the layout, as well as the bulbs in the switch controllers themselves. There's no bulbs in any of these anymore. Use of the bulbs will affect the voltage on the overall circuit, so this will affect the optimal resistance values you can use when hooking up an MTH signal to indicate the position of your switch tracks. So just be aware of that if you're going to use the bulbs. Well, we hope you found this seminar enjoyable as well as informative. Now we're going to turn things back over to Sam. Elroy Electrical signing off. Elroy had told me everything checked out, so we ran a test train to see how things operated. Now we'd like to present a current view of the railroad. It's been a while since the last video, but we have been busy. The buildings are placed about where they're going to end up. The rocks and trees are not, the final locations are not at all determined yet. We found a great way to separate the railroad from the rest of the room with these dividers. And our next step here is to put the background in. Then we'll get to the detailed scenery. So in the meantime, let's run some trains, and I want to mention that all the locomotives are powered with sound. It's a Protosound 1 based, MTH Protosound 1 based system. Well, that's it for now. See you next time on Charon View when we talk about how we control this little railroad. And until then, have fun with your trains.